So day 5 notes is solving logarithmic equations. We're going to start with baby steps in this lesson, and we're going to work our way up to more difficult ones. A lot of time when you're doing these, there's so many different ways you can approach every different problem. So there's no way you can memorize these. So it is absolutely critical that you kind of understand what logarithms are, being able to go from exponential form to logarithmic form and vice versa. So let's take a look at a couple of examples. So anytime you just have one logarithm, a lot of times what we do is we rewrite it in exponential form. So when I look at this example here, right, we're actually going to convert log base 5 of x equals 3 to exponential form. So right away when I do this, when I go ahead to do this, I look at it and I'm going to say, this base of 5, right, to the third power will equal x. So right away, this is an easy equation to solve because all I have to do is simplify 5 to the third. And 5 to the third is 125. Now you could easily check your answer via the calculator. I'm just going to go here and I'm going to say math. I'm going to go up to log base. I'm going to go log base 5 of 125, hit enter, and it should be 3. And does that equal 3? It does. So example 2, very similar. We're going to take this log, right, and we're going to write it in exponential form. So 3 to the third power is equal to 3x minus 2. So 3x minus 2 equals 3 to the third, right? 3 times 3 is 9, times 3 is 27. And now I'm going to go ahead and solve for x. So I get 3x equals 29, divide by 3, and x is equal to 29 over 3. Okay? Now, the next one, right? When you look at this example, remember, there's two ways we can approach this. Natural log is basically log base e. Well, if you remember what we said a minute ago, or in an earlier lesson, that log base e of e to the negative 2x, when this base and this matches up, it basically wipes it out. So it's almost like if I did log base 2 of 2 to the third, right? What is that going to be? Well, if I think about it, 2 to the third is 8, and log base 2 of 8 is equal to 3, because 2 to the third power is 8. So this kind of wipes that out and just leaves me with this. So this answer, this already simplifies to negative 2x equals 8. And when I divide by negative 2, x is equal to negative 4. All right? And you could easily check your answer on this one, because if you think about it, log base e of e to the negative 2x is equal to 8. So right away, if you think about it, e, right, to the 8th power is equal to e to the negative 2x power. What does x have to be to make that a true statement? 4, negative 4. Next one. This is a little more complicated now, right? So now I have to take this 6, I'm going to raise it to the 5x plus 3, and that needs to equal 36. Well, now this goes back to, the last chapter when we solved these exponential equations. I look and I notice I can write both of these as a base of 6. So I have 6 to the 5x plus 3 equals 36 is equivalent to 6 squared. So now all I have to do is set these equal to each other. 5x plus 3 is equal to 2. 5x is equal to, subtract 3 from both sides, and you get negative 1. So when we subtract 3, you get 5x equals negative 1. I divide by 5, and x equals negative 1/5. Now I could easily check my answer here by plugging it back in. So if I do 5 times negative 1/5, right, I get log base 6 of 36 equals, this would give me negative 1, right, and negative 1 plus 3 is 2. Now, is 6 to the second power equal to 36? Yes, we're all good. All right. Now, example 5. If I think about it, if log base 4 of x plus 2 is equal to log base 4 of 8, what you have to know is if these values are the same, right, that will be a true statement. So when you have a log equal to a log and the bases, and you have to understand that these bases have to be the same. If that's the case, all you know is these have to be equal. So x plus 2 should equal 8, which means x is equal to 6. So when I look at the next one, again, same bases, I'm good. Now I need these to be the same. So what is the value of x that makes those equal? I set them equal to each other and subtract x, add 7. I get 3x equals 12, x equals 4. All right. So with this solving, this is one, or these are a few types of different types of solving, and we're going to be adding more and more each time. All right. So go ahead, try the homework, and